Hello everybody, hope you're doing well. I'm Nasser Atai, independent researcher from Afghanistan. Today, I'm going to talk about the Fourier inverse equation, one of the most important equations in quantum mechanics. The equation, the inverse Fourier transformation and transform. So here the equation f of x equals 1 over square root of 2 pi of integral of negative infinity to positive infinity of f tilde of k e to the ikx of dk. This equation called the inverse Fourier transformation or transform. What does this equation mean in one sentence? It reconstructs a function in a space or time from its frequency or momentum components. What is a function? What is f of x? In this video specifically, I'm gonna explain each part of this equation: f of x, the square root of 2 pi, the fraction, the integral, f tilde of k, e to the ikx, I, k, and x, dk, everything, right? Then you will understand one of the most important equations in quantum mechanics. What is a function? What is f of x? A function is a rule that assigns one output value to each input value. Like input value, like variable, outer value, like the value of the function, right? Like we have, for example, f of x equals x squared, right? So we have input and output, right? The output is the value of the function, like x squared. The input is the variable, like f of x, right? And what is f of x here, right? In this equation, what is f of x? That depends on the field. When we say f of x, we talked about that it's a function. It has an input and output, right? But the meaning of f of x really matters, and it depends and varies in different fields. In quantum mechanics, different, and maybe in all the fields are different, right? So, like in receiving the signals, it may function differently. So in quantum mechanics, f of x is wave of x, right? It's a wave function. A probability amplitude of finding a particle at position x, and in quantum mechanics is a wave function, generally speaking. In signal processing, f of x is signal amplitude in the time or space. In physics, it's a wave. F of x displacement, field strength, intensity, etc. Something important that you should know. Here we do not replace x with any number. So it is a function. We do not need to replace with any other numbers. Just f of x, right? X is a coordinate, not a variable to solve for. It's a coordinate, a spatial coordinate in space, right? So what is x? Understand this. X is the spatial coordinate. It labels position in space. And time problems, it can be changed to t, the time, right? Not x. So f of x, value of the function at position x. Then what is f tilde of k? F tilde of k, right? So f tilde of k, this is the Fourier transform of f of x, or this is the transform of function. It lives in the frequency or momentum domain. It tells us how much of frequency k exists in the function, like how much frequency exists in a function, right? Relationship f of x f of x is the space domain. F tilde of k is a frequency domain. If you don't know the difference between a space domain and frequency domain, you can search about it. It's not difficult as much as you think. They describe the same physical reality just from different perspectives. What is k? K is the wave number. It means spatial frequency. Physically speaking, is k equals 2 pi over lambda. So meaning, if we have a large k, it means there are rapid oscillations. If we have a small k, we have slow oscillations. In quantum mechanics, we have P equals h bar times k. K is the wave number, generally speaking, right? So why do we use integrals? This is very important. Why integral, not a sum? You need to make sure to understand two things. One, discrete and continuous. We mostly use integrals with continuous, not and somewhat discrete. So because frequencies are continuous, they're not discrete, right? The integral means add up. The integral means add up contributions from all possible frequencies. Like you're gonna say add up this person with this person with this person with this person, and you get something. This is called the integral, right? You're just gonna sum up all possible frequencies. Why from negative infinity to positive? Why we write the integration of negative to positive infinity? So because to talk about all frequencies, right? To include all frequencies, positive and negative frequencies, full information of the wave. One key point: we don't calculate infinity directly. It is a conceptual limit, meaning completeness, right? So what is decay? So d is infinitesimal or infinitely small. K, as we say, that is wave number. So decay is infinitesimal slice of frequency, meaning the integral adds infinitely small frequency contribution, like very small frequencies contribution together, and to integral we add them. Like we just put an integral and we just add all possible frequencies, negative to positive frequencies in a spatial domain. Together, they reconstruct the full wave. Like we know the derivative, we want to take the derivative, and if you want to reverse that, we use the integrals. Like simple equation we have, like v equals dx over dt. This is a derivative. I mean, velocity is a change of position over time. So if you want to reverse back to find the place, we can take the integral of that, like multiply both sides by dt, and then we have to cancel out these two. We have dx equals v dt. Then we just integral both sides. The integral of dx is only x plus c. We just write x equals integral of v of t of dt plus c. So this is a very basic example of how we can reverse or reconstruct something from by integral. Like we have the velocity, and by these putting all velocities together, we can find the what we call the place, displacement, and the position of an object with respect to time. So this is a basic meaning of an integral, right? Hope you understand this. Okay, what is the exponential I to the e to the ikx? So what is e? E is approximately 2.71828, base of natural logarithms. So what is I? I know you all of you understand I is the square root of -1, right? What is e to the ikx? So e to the ikx is actually comes from using Euler's formula, like e to the ikx equal to cosine of kx plus I sine of kx, right? Okay, right. So this represents a wave, a complex oscillation. It converts frequency information back into space. As I have talked about here, this is somehow an analogy to understand how we use integral to put up infinitely amount of frequencies or velocities together. Here, velocities to find the position. But in this case, we put an infinitesimal amount of frequencies to convert our reconstruct to its actual shape, right? What is the rule of e to the ikx in the integral? So it maps frequencies in space. It tells us how its frequency contributes at position x. Why do we multiply everything together? So inside the integral, f tilde of k times e to the ikx times k, meaning f tilde of k, strength, amplitude, e to the ikx, wave shape, decay, tiny frequency. Then integrating that, summing all waves. It means we just sum all possible waves in the spatial domain and put them together to reconstruct real shape. Why the factor of 1 to the over the square root of 2 pi? First of all, why a fraction? Why we use a fraction here? Because this is an inverse transform. It ensures perfect reconstruction, no loss of energy, mathematical symmetry. Why square root? Okay, this is also important. A forward and inverse transformation share normalization. If you don't have information on normalization, you can search about that. It's a concept that mostly is in quantum mechanics. Forward and inverse transforms share normalization. Each gates a factor of square root of 2 pi. This is balanced scaling. Why 2 pi? Because one full cycle is 2 pi radians. Waves are naturally periodic in 2 pi. Comes from angular frequency and Euler's formula. I make sure one thing, the square root does not mean have a cycle. It's a normalization. It's not geometry. Right, so big picture of everything we talked about. This equation generally says a function in a space is made up of infinitely many waves. Each wave has a frequency of k. The amplitude of each wave is f till of k. Adding all of them gives back the original function. Physical interpretation in quantum mechanics. F of x is a position at a position and a space wave function. F tilde of k is a momentum space wave function. So Fourier transform connects position to momentum. This is why uncertainty principle exists. This is why space and momentum are dual. Final summary of this lesson. So f of x, or the function of x, a sum of all frequency waves weighted by their amplitudes. So in this lesson, I have introduced everything about the formula, the Fourier inverse transform, and hope you understand something from what I explained to you. And now you have full background about this formula. F of x equals 1 over a square root of 2 pi of integral of negative infinity to positive infinity of tilde of k, f tilde of k of e to the I kx of dk. So I've described each part clearly and explained why they are in this function, in this equation. What are their uses and what are their uses in this equation, and how the functions and why we put them in this order, why we use each part. So for today's video, I think that's up, and if you have any question, you can ask directly. So for this video, that's up. Goodbye, everybody.